Good morning, children. In the previous class, we have discussed about atomic radius, ionization energy, isn't it? So, ionization energy is a minimum energy required to remove an gaseous electron from an atom in its ground state. So, this ionization energy is otherwise called ionization enthalpy, and ionization energy is measured in kilojoules per mole, isn't it? Right. Today we are going to see about there are some factors which affect the ionization energy of an element. What are the factors? Let us see now. The first one is nuclear charge. Second factor is screening effect or shielding effect, penetration power of the orbitals, stable electronic configuration, and finally atomic radius. So these are some of the factors which affect the ionization energy of an element. First one is nuclear charge. If nuclear charge is more, ionization energy is also more. Screening effect. Screening effect, it is otherwise called as shielding effect. Okay, screening effect is otherwise known as shielding effect. More shells with electrons between the nucleus and the valence shells, they act as screens. Okay, and also it decreases the attraction over the electrons. So hence it is called as screening effect. Screening effect, it is otherwise called shielding effect. The valence shell, okay, here more shells with electrons between the nucleus and the outermost orbit, that is valence shell. Actually they act as screens. Okay, these electrons, they act as screens and they decreases the nuclear attraction over the electrons. And this shell act as screens and it decreases the attraction, nuclear attraction over the electrons. This is called the shielding effect. If screening effect or shielding effect is more, ionization energy will be less, right? Next one is the penetration power of the orbitals. Penetration power depends on the shell and the subshell. Penetration power of an electron, it reduces the attraction. Okay, the penetration power of an atom transmitted an electron, it transmitted from a particular substance. So the power of an electron transmitted for a substance, that is the penetration power. Penetration power actually depends on shell and the subshell. Okay, and S subshell has highly penetrating power because this S subshell highly penetrated, that is it attracted towards the nucleus of an atom. That is why S subshell has highly penetrating power. Next one is stable electronic configuration. It means an atom in which the outermost valence shell is complete, then it is called the stable electronic configuration. Okay, if an atom has stable electronic configuration, means in that case an atom in which the outermost valence shell is complete. This is the stable electronic configuration. Next one is atomic radius. In the previous class we have discussed about atomic radius. Atomic radius is defined as the distance between the center of the atomic radius of an element is defined as the distance between the center of the nucleus and its outermost shell containing the valence electrons, isn't it? So if atomic radius is more, ionization energy will be less. Okay, and already I told you ionization energy, it is measured in kilojoules per mole, right? Okay, so these are some of the factors which affect the ionization energy of an element. What are the factors? Nuclear charge, screening effect or penetration power of the orbiter, stable electronic configuration, followed by atomic radius. Got it? Right. Next we can move to the ionization energy increases along the period. Variation we can see now. Okay. Ionization energy increases along the period. Why? Because more shells, more energy is required to remove the electrons. Okay. Here more energy is required to remove the electron. That is why ionization energy increases along the period, whereas ionization energy decreases in a group. Why? Because here the valence electrons are loosely bound, so they require less energy for the removal. That is why ionization energy decreases down the group. Okay, so this variation you can get the 2-mark questions. In 2-mark questions, so ionization energy increases along the period. Why? Because more energy is required here to remove the electron. That is why ionization increases along the period from left to right. At the same time, from top to bottom, ionization energy decreases along the group. Why? Because here the valence shell are loosely bound. The valence electrons are loosely bound, so they require less energy for the removal. That is why ionization energy decreases down the group. Okay. Next we can move to electron affinity. What is the meaning for affinity? Affinity means attraction, right? Affinity means attraction. So electron affinity is defined as the amount of total energy released when a gaseous atom to form its anion. Okay, here the energy released from a gaseous atom to form its anion. This electron affinity is also measured in kilojoules per mole, like ionization energy, right? So electron affinity is defined as the energy change that occurs. Here the energy released when an electron is gained by an atom. Okay, the energy released when a gaseous atom is gained by an electron in its gaseous state. That is the energy change. Electron affinity is defined as the energy change that occurs when an electron is gained by an atom in the gaseous state. This is the definition for electron affinity. So, for example, see, A is a gaseous atom. Okay, so this gaseous atom gains an electron to form anion. Anion means minus, negative charge, right? To form A minus, as well as energy is released. Energy released means what? Liberation. It involves the liberation of energy, right? So next one is chlorine. Chlorine is also a gaseous atom. So this chlorine atom gains an electron. E minus is nothing but electron. Okay, chlorine atom gains an electron to form chloride ion. Cl minus is anion. That is the chloride ion. Along with that, energy is released. This is called the electron affinity. And electron affinity is also measured in kilojoules per mole. Okay, so electron affinity is defined as the energy released when an electron is gained by an atom in its gaseous state. Okay, this is applicable only for gaseous elements, atom. Okay, next we can move to electronegativity. Electronegativity is defined as the tendency of an atom to attract the shared pair of electrons towards itself in its ground state. Okay, so this is called electronegativity. So, for example, we can consider the hydrogen chloride molecule. Here, hydrogen as well as chlorine atoms, they share one electron each to form covalent bond between them. Covalent bond means what? Mutual between them, right? Here, when you compare the hydrogen atom, chlorine atom is highly electronegative atom. Okay, chlorine atom has highly electronegativity in nature, so it attracts the shared pair of electrons towards itself more than hydrogen atom. So due to this, the bond breaks. Here, the bonding electrons are left with hydrogen and chlorine to form H plus and Cl minus. Okay, so electronegativity means electronegativity of an element is defined as the ability of an atom in a chemical bond to draw the bonding electrons closer to itself. This is called electronegativity. Okay. Pauling scale is mainly used to determine this electronegativity. What is that? Pauling scale. Pauling scale is mainly used to determine the electronegativity. So some of the values of electronegativity values of some elements are given here. We have to go through all these elements electronegativity value. Okay. So this Pauling scale is mainly used to determine the electronegativity value. That it gives the electronegativity value, and it is mainly used to determine whether the given bond is having given atom as having ionic character, or otherwise whether it has covalent character. For that purpose it is used. This Pauling scale is used to determine whether it contains ionic character or covalent character. The element contains ionic character or covalent character. See, this one is H. H is nothing but hydrogen element. Okay. What is the electronegativity value of hydrogen element? It is 2.20. Next one, Li is lithium element. Its electronegativity value is 0.98. Be is beryllium. Value is 1.57. For boron, electronegativity value is 2.04. For carbon, it is 2.55. Nitrogen 3.04. Oxygen 3.44. And for fluorine atom 3.98. Here, sodium atom is given. Its electronegativity value is 0.90. For magnesium atom, it is 1.31. For aluminium, 1.61. Silicon, 1.90. Phosphorus, 2.19. Sulfur, 2.58. And chlorine, for chlorine, 3.16. Next, K is potassium. Its value is 0.82. For calcium, it is 1. Gallium, it is 1.81. Germanium, it is 2.01. Arsenic, the electronegativity value is 2.18. For selenium, 2.55. And for bromine, the electronegativity value is 2.96. So Pauling scale is mainly used to determine the electronegativity value is given to find out whether the atom contains ionic character or otherwise it's having covalent bond, covalent character like that. Okay. So this value is very important. You can get questions in NEET. Okay. So values you should remember, children. Okay. Good. Right, children. Now we can move to the variation of electronegativity along the period as well as a group. Electronegativity increases along the period. Okay. Electronegativity increases along the period because of the increase of nuclear charge. Okay. Nuclear charge increases. That is why electronegativity also increases along the period. Whereas if you take group, the electronegativity decreases. Electronegativity decreases in your group because of the increased number of energy levels or shells. Okay, so this is a variation of electronegativity along the period as well as a group. Electronegativity increases along the period from left to right. This is because of the increase in the nuclear charge, whereas electronegativity decreases in metals are electropositive character. What is meant by electropositive? Electropositive means an atom which tends to lose electrons to form cation. This is called the electropositive, right? Electropositive means an atom which tends to lose electrons to form cation. For example, lithium, sodium, potassium, these elements tends to lose electrons to form positive ions, that is cation. At the same time, if you take the next one, what is that? First we saw about the metals we saw. Next, if you take the electronegative elements, electropositive character we saw. Electropositive is nothing but an atom which tends to lose electron. Whereas if you take electronegative electronegative characters means here an atom which tends to gains electron to form anion, that is negatively charged ion. Okay. For example, fluorine, chlorine, bromine, iodine, these are some of the atoms which tends to gain electrons to form anion. This is the electronegative character. Okay. So, electropositive character means an atom which tends to lose electrons, whereas electronegative character means an atom which tends to gain electron to form anion, right? Okay, if you take the periodic table, the elements are arranged, that is, it is arranged, some of the elements are metals, some elements are non-metals, whereas some elements are metalloids, isn't it? So, in the periodic table, all the metal elements are arranged in the left hand side, whereas non-metals are arranged in the right hand side. If you take the first or third group, you can take the third period. Okay. So what are the elements are present in the third period? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, like that, isn't it? So if you take sodium and magnesium, sodium and magnesium are metals. So it is present at the left hand side of the periodic table. Whereas if you take silicon, phosphorus, silicon is nothing but a non-metal. It is a metalloid. It is having the metallic character as well as non-metallic character, right? Whereas phosphorus, sulfur is present here. Sulfur is nothing but a non-metal. So metals are present in the left hand side, whereas non-metals are present in the right hand side. Okay. Here you should know two things about the metallic character as well as non-metallic character. Generally, metals are electropositive elements. Here, these atoms tend to lose electrons to form cation, that is positive ion. Example, Li2+, Na+, K+. These are positive ions. Okay. Here, the atom which tends to lose the electrons, whereas electronegative character means it is nothing but an element which tends to gains the electron to form anion, negatively charged ion. Example, fluorine, chlorine, bromine, iodine. These are okay. So all the metal elements are present in the left hand side of the periodic table, and non-metal elements are present at the right hand side of the periodic table. Even though metalloids are also present at the center, right hand side of the periodic table. Most electronegative element which is present in the periodic table is fluorine element. Okay. So here where is fluorine element? So this is the fluorine element. So fluorine element is the most electronegative element which is present in the periodic table. Whereas least electronegative element is cesium. Cs is cesium element. Got it? Right. Next we can move to merits and demerits of periodic table. What are the merits? What are the advantages of periodic table? What are the disadvantages? First let us see the merits of periodic table. Here all the elements are based on the atomic number. Already I told you there are 118 elements are present in the periodic table, and all the elements are arranged based on the increasing number of atomic number, isn't it? So that is one of the merits of periodic table. are related to electronic configuration. All the elements are arranged based on their electronic configuration, right? Next one is periodic properties show the gradual variation at regular intervals of time. What are the periodic properties? Periodicity means what? First, anything which repeats itself after a regular interval of time is called periodicity, and this behavior is called the periodic properties. Okay. So what are the general periodic properties? Atomic radius, ionic radius, covalent radius, ionization energy, electron affinity, electronegativity. These are some of the periodic properties, isn't it? Right. So periodic properties, it shows the gradual variation at regular intervals of time. That is also one of the merits in the periodic table. Next one is, it is very easy to remember and also it's very easy to understand, right? So these are some of the merits of the periodic table. Next we can go to the demerits. What are the demerits of periodic table? Here, the first demerit is position of hydrogen is not satisfactory. So hydrogen is the first element which is present in the periodic table at the top, isn't it? Left hand side top. But this position is not satisfactory, so it will come under the demerit. Position of hydrogen is not satisfactory. Next one, it fails to accommodate the inner transition elements. The inner transition elements are lanthanides and actinides. So these inner transition elements are not accommodated here in the center of the periodic table. So it is one of the demerit. Fails to accommodate the inner transition elements. Next, few elements are not arranged in electronic configuration. 118 elements are present in the periodic table, but majority of the elements are arranged based on their electronic configuration, but only few elements are not arranged based on the electronic configuration. So this is one of the demerits. Okay, so what are the merits? Based on all the elements are positioned here based on the increasing number of the atomic number. Next, position of elements are related to electronic configuration. And the periodic properties shows the gradual variation at regular intervals of time. Next, it is very easy to understand. Okay, and we can easily remember the elements also because we are using symbols, and based on the atomic number we can easily understand the elements. Next, demerits are position of hydrogen is not satisfactory, fails to accommodate the inner transition elements like lanthanides and actinides. And the next one is few elements are not arranged based on their electronic configuration. So these are the demerits of periodic table, right children? Okay. Now the portion has completed periodic classification lesson. You will get the assignment, children. So try to complete the assignment and go through all the contents what we have discussed today, right? You have to submit your assignment in the WhatsApp group without fail. Okay. Next coming week you have to submit your classroom notebooks for correction purpose as well as for checking purpose. Keep this in your mind. So try to complete the assignment and send it through WhatsApp group. Thank you children.